Hello, welcome to another edition of the COVID-19 show. And today I want to talk about set 12, problem 11. Now this is kind of a theoretical problem, but I think it's a really good one to talk about the power of linear operators. Okay, so the idea is you have three solutions to this non-homogeneous ODE with the g of t on the right-hand side. They all have initial conditions. And we want to find a solution to this homogeneous ODE with a 0 on the right-hand side. Okay, and we're going to be using the property of linear operators. Now the first thing is, what does it mean to say that y1 of t satisfies this initial value problem? What it really means is if I replace the unknown function y by y1, it's true. So in other words, I could just turn this y into y1. Okay? So L of y1 is g of t. y1 of 0 is 3, etc. It's a little bit like saying I have an equation x squared equals 9. It's an equation for an unknown number x. Okay? There are two solutions. x1 is 3 and x2 is negative 3. There are two solutions. And I might say I could substitute one of these in and say x1 squared is 3. So x1 squared is 9, right? So here x is the variable unknown, and here x1 is 3, right? So it's the same kind of thing here. y1 is some explicit function. We just don't know what it is, right? Okay. So let's move on. So the same thing, y2 satisfies this, so if I put a 2 in here, everything is good. And I put in a 3 here, everything is good. So this whole thing is just a fancy way of saying these three facts. In fact, after I replaced y by y1, etc., I can just get rid of this. Because everything about y1, y2, and y3 is now summarized over here. Okay, so now let's think about this linear combination. Now the important thing about linear operators, right, is that the linear operator on the linear combination is the linear combination of the linear operators. Well, let's just say this. All right, let's just go straight to it. So I want to substitute in this thing, c1y1 plus c2y2 plus c3y3. When I want to choose c1, c2, and c3, so that equals 0, right? But let's first use the linear operator stuff about it. This is c1 times L of y1 plus c2 times L of y2 plus c3 times L of y3. And I want to set that equal to 0. Right? But what is L of y1? Oh, it's g of t. That's g of t, g of t. So what it really means is that c1g of t plus c2g of t plus c3g of t equals 0 for all t. Or that c1 plus c2 plus c3 all times g of t is 0 when I factor out the g. Well, that just gives us the first of our three equations for c1, c2, and c3, and that is that c1 plus c2 plus c3 is 0. Right? Because this constant times g of t has got to be the 0 function, so that constant's got to be 0. Okay? All right. Now the next thing is we've got to, so we've satisfied that. If c1 plus c2 plus c3, this linear combination satisfies that. Now we want to satisfy the initial conditions. Well, what is y of 0? If I apply, I get y of 0 for that linear combination is c1 y1 of 0 plus c2 y2 of 0 plus c3 y3 is 0, right? But I know what y1 is 0 is. That's 3. This is equal to c1 times 3 plus c2. What is y2 of 0? Negative 2. Plus c3 times what is y3 of 0 times 1. And I want to set that equal to negative 5. Because I want to choose c1, c2, and c3, so y of 0 is negative 5, right? So that gives me the equation when you usually write c1 times 3 as 3c1, right? Minus 2c2 plus c3, that should be negative 5. So now we've taken care of this one. Similarly, if I put primes everywhere, not that prime, but primes here, and put primes there, all right, so that's y prime of 0 is c1 times 2 plus c2 times 2 plus c3 times 1, and that should equal negative 4. Right? So that means that 2c1 plus 2c2 plus c3 equals negative 4. Right? And now we've taken care of that initial condition. So we want to satisfy the homogeneous ODE. We want to get these two initial conditions. So let me box that. Not that we're done, but this is the halfway step. Now we have to solve these for C1, C2, and C3 and put it in WeBWorK. All right, so I'm done with this. All I needed to know about y1, y2, and everything is now gone. We just need to solve this for the constants. All right. So one of the ways you can solve this is by using row reduction on your calculator. I want to go through that a little bit. I want to do this by hand, actually. I'm going to do row reduction by hand. So this system is equivalent to the system 1, 1, 1, 3 minus 2, 1, 2, 2, 1. I take this matrix here, multiply it by C1, C2, C3, column vector, right? First, I get C1 plus C2 plus C3, and that equals 0. And then I have negative 5 and negative 4. So this system is equivalent to that one. And then I can write this as the augmented matrix, 1, 1, 1, 0, 3, negative 2, 1, negative 5, 2, 2, 1, negative 4. And we often put a little vertical bar there, dotted line. Okay, so everything about this system is encoded in that augmented matrix. Okay, I can find the reduced row echelon form of that matrix, and I'm going to do that by hand, but you can do that in your calculator. So what we're going to do is do elementary row operations to this matrix. Okay. Let's see. What am I going to do? The first thing I want to do is I want to keep this first row the same, but I want to put a 0 here and here. And I do that by taking that row minus 3 times that one. So that row, 3 minus 3, and I get not minus 2 minus 3 times 1 is minus 5. 1 minus 3 times 1 is 1 minus 3, or negative 2. And then I get minus 5 minus 3 times 0. Okay. So then I get that third row minus twice the first. I get a 0, I get a 0, get a minus 1, that, I get a minus 4. And this little wavy line means the result of an elementary row operation, or or more than one here. Okay, now let's see. I can take this row, multiply it by -1, that row. So let's get rid of the negatives. Okay. Now I can put a 0 here and here by taking that row, subtracting twice the third of that row, subtracting that. So this goes to 1, 1, 0, -4. And this goes to 0, 5, that minus twice that, 0. And that minus twice that is 4 minus 10 is, let me see, 5, I take 2 minus 2. 5 minus 8 is -3. Okay, and then I have 0, 0, 1, 4. All right. So now I want to make that a 1 by multiplying this second row by a fifth. So I have 1, 1, 0, -4, 0, 1, 0, -3 fifths, 0, 0, 1, 4. So now all I have to do is I want to put a 0 up here. I take that row minus that one, and I get 1, 0, 0, -4 minus -3/5, so that's plus 3/5, and I have a 0, 1, 0, -3/5, 0, 0, 1, 4. And then this thing that's minus 20/5 plus 3/5, so this thing here is actually -17/5, right? All right, so that means the system is really C1 plus 0 C2 plus 0 C3 is -17/5, and then I have a 0, which I won't write, plus C2 is -3/5, and I have C3 is 4. Okay, let's see if that's what I did before. -17/5, yeah. So actually, this is right. So the answer that you plug in WeBWorK is that C1 is -17/5, C2 is -3/5, and C3 is 4. And there you're done. All right, thanks. I hope you're staying healthy. I hope you're getting enough to eat. I hope you're warm. I hope you're doing okay. So I'm always here if you want to send me email. And we're having Zoom sessions frequently. Okay, so goodbye.